versus bottled water lesson in case you're having a little trouble with the ideas of the histograms we're about to see. So what we're looking to do is to compare baseline and post data that you will your students will end up generating, and look at some before and after stuff. So your students will be creating a histogram on graph paper. If you're having trouble finding graph paper, there is some in the math department. Just see a math teacher if you don't have any. You will need to have them labeled both the X and Y axis for the 5 parts of the scale. We'll have agree, strongly agree, undecided, strongly disagree. Let's go to disagree. So review activity. Here, this is just kind of getting them to think about the ideas of sampling things in the future and going from there. So let's take a look at the actual lesson itself. So in case you forget from math class, a histogram is very much like a bar graph. There is a video here, but essentially it is a bar graph where we have our various categories. In this case, strongly agree, undecided, disagree, strongly disagree. So you're going to have students are going to need to take this data. They're going to record their answers here. And then here would be their frequency. When they say relative frequency over here, you're going to have them take the number that responded strongly agree and divide that by the total number of responses. Quick estimate here, total number of responses should be matching the kids in your class. So if 10 kids are in your class that day, all your relative frequencies should be out of 10. So here with this, they are going to collect the data. Bottled water is safer than tap water. See if they agree or disagree. Bottled water is cleaner than tap water. Again, same thing. Bottled water tastes better. Again, same thing, just recording the results there. Now they're going to have to make the histogram based off of what they've seen. The x-axis should be the response of strongly agree, undecided, disagree, strongly disagree. Over here will be your frequencies. Now this counts up by 5s all the way to 40. I hope none of your advisories are as large as 40. You can change the scaling of that axis to be more appropriate. If it was 15 kids in the class, you probably can get away with counting by 1s, maybe even if it's 20, but once you get above that, you may want to switch. Every block is 2 or something like that. Your y-axis will be, of course, the number of responses, so that will be the title over there. So they're going to take that data for each one, title, describe what the graph is about, so they should have one for each of the following. Bottled water safer than tap water, bottled water cleaner, and bottled water tastes better. So they would just put that title on each one of those and graph that data. And at the end, they'll be turning in those graphs. So what it should look like in the end, you should be getting 3 of these. Keys to look out for. That title on the x-axis saying that these are the responses. Each response down here. Title on the y-axis saying frequency, and your numbers going up. It should be accurate bars. Now, one thing with a histogram, since these are individual categories, you notice we have small gaps between them. That is a difference between a bar graph and a histogram. Is a histogram actually, since it's not continuous data, they just space them out. More of a minor detail to bring home with your students, but detail nonetheless.